What if I told you that everything you believe about the speed of light is fundamentally wrong? Not wrong in the sense that Einstein made a mistake, but wrong in the way that you've been looking at a mountain your entire life, and someone finally points out you're standing on it. Here's what will blow your mind. Light isn't fast. Light just happens to be the speed at which our measuring tools break. Think of it like someone measuring how deep the ocean is by dropping a stick. The stick sinks to a certain depth, floats back up, and they say, well, that's how deep the ocean must be. Except that's not the ocean. That's just the limit of their stick. For 137 years, since Maxwell published his equations in 1865, we've treated 299,792,458 meters per second as this cosmic speed limit, this absolute wall that nothing can cross. But what if light reached that speed, not because nothing can go faster, but because that's where reality stops cooperating with our perception? Here's the question I want you to sit with for the next 230 minutes. What if the universe isn't hiding things faster than light? What if the universe is hiding things that we literally cannot measure because we've built our entire measurement system on light itself? Before we dive in, I want to ask you something. I'm broadcasting this from a studio, but I want to know, where are you watching this right now? Are you in Tokyo, Sao Paulo, Lagos, Mumbai? Drop your country and your current time in the comments. Because here's the thing. Light from the sun took 8 minutes and 20 seconds to reach wherever you are right now. But there's so much more happening in that invisible space between here and there that we've completely overlooked. And hey, if this first minute already has you thinking differently about reality, smash that subscribe button and ring the notification bell. Because we're about to spend the next 4 hours demolishing everything you thought you knew about speed, measurement, reality, and your place in this absolutely mind-bending universe. Let's go. What would happen if I told you that nothing we measure is actually real? It's just a shadow of what's really happening. Before we talk about what light is or isn't, we need to destroy something beautiful, the idea that measurement is neutral. It's not. When Albert Einstein showed us in 1905 that the speed of light is constant always, 299,792,458 meters per second, no matter how fast you're moving when you measure it, he was actually revealing something darker. He was showing us that reality adapts to our measuring tool, not the other way around. Think of it like this. Imagine you're trying to measure the speed of a soccer ball. You stand still. It passes you at 20 miles per hour. Now you run toward it at 5 miles per hour. Normal physics says you should measure it at 25 miles per hour. But light doesn't work that way. Light always measures as exactly the same speed, no matter how fast you're moving. That's not a feature of light. That's a feature of how the universe accommodates light as a measuring instrument. Let me introduce you to someone whose work we'll return to, Hermann Minkowski, a mathematician who died in 1909. But before he died, he did something revolutionary. He looked at Einstein's mathematics and said, these equations aren't describing time and space. They're describing something else entirely, a unified thing we should call spacetime. And here's the mind-blown moment. Minkowski proved mathematically that the speed of light is actually the speed at which time and space convert into each other. Wait, let me say that again. The speed of light isn't the speed of light. It's the conversion rate between time and space. It's the cosmic currency exchange. When you travel through space faster, you travel through time slower. They're literally the same transaction. Light moves at the point where that exchange is perfectly balanced. Think of it like a bank. You have an account with 100 units. You can split it any way you want between space and time. Put all 100 into space, and you barely age. Put all 100 into time, and you don't move. Light puts exactly 50 into each, and that balance point is always 299,792,458 meters per second. That's not light being fast. That's light being perfectly balanced. Here's what this means. If light were traveling faster, it wouldn't be light anymore. It would be something else entirely. And here's the revolutionary part. What if that something else already exists, but we can't measure it because we're using light to do the measuring? It's like using a thermometer to measure color. The thermometer breaks and you say, "There's no heat here." But there is, you just chose the wrong tool. In the next section, we're going to explore what physicists have been finding for the last 50 years, measurements of things that are supposedly impossible. Things that violate the speed of light. Things that shouldn't exist. Spoiler alert, they exist. And it's going to make you question whether scientists are lying to you or whether we've all been asking the wrong questions. Have you ever heard of tachyons? Probably not. And that's not an accident. Let me take you back to 1962. A physicist named George Sudarshan proposed something that made his colleagues deeply uncomfortable. He suggested that there might be particles that always travel faster than light. Not sometimes, always. He called them tachyons, from the Greek word for swift. Here's the thing that still blows my mind. We haven't ruled them out. In fact, in 2011, scientists at CERN thought they detected them. Neutrinos traveling faster than light. The experiment was so significant that they published it before peer review because they wanted help finding their mistake. And you know what? They did find their mistake. The measurements were wrong. And this is crucial, they couldn't prove that tachyons are impossible. They just proved their measurement was wrong. That's different. Think of it like this. A magician performs a trick you don't understand. You say, "That's impossible." Then you see how it was done. But the trick doesn't stop being impressive. It just means your understanding of impossible was limited. Now, let's talk about something even weirder that we do know exists. Quantum entanglement. In 1997, an experiment by Alan Aspect proved something that even Einstein hated. Two particles can be connected in such a way that measuring one instantaneously affects the other, even if they're on opposite sides of the universe. Not eventually, instantaneously. Faster than light could possibly travel between them. Einstein called it spooky action at a distance. And he was deeply, deeply bothered by it. Here's the mind-blown moment. Einstein died in 1955, believing that quantum mechanics was incomplete, that there had to be hidden variables we hadn't discovered. But in 1964, John Bell proved mathematically that those hidden variables couldn't exist. There's no way to fix quantum entanglement. It's fundamentally faster than light. Yet somehow, light is still the speed limit. Here's the cognitive dissonance I want you to feel. If A is true and B is true, and A contradicts B, then at least one of them isn't actually true. But what if both are true? And the problem is our definitions. Think of it like this. You're in a dark room with two doors. You're told the door on the left leads to heat, and the door on the right leads to cold. You open the left door and find cold air. You open the right door and find heat air. You conclude one of the doors must be mislabeled. But what if the doors aren't mislabeled? What if heat and cold were never the right words to describe what's on the other side? Let me introduce you to another scientist, Juan Martin Maldacena. In 1997, this physicist proposed something called the ADS-CFT correspondence. It's complicated, but here's the simplified version. The universe we see might be a holographic projection of a universe with fewer dimensions, like a 2D shadow of a 3D object. And here's what's important. In this holographic universe, information doesn't travel at light speed through space. It travels instantaneously through the deeper space, the real space, and only appears to travel at light speed in our shadow universe. What if light speed is just what happens when you try to send information through a shadow? I want you to pause for a moment. Seriously, pause. Think about the last time you tried to explain something to someone and they just didn't understand. You said it 5 different ways, right? What if the universe is doing the same thing with light speed? It's trying to tell us something's not working, and we keep saying, yep, light speed is the limit, instead of asking, what are we failing to understand? Type in the comments, what's something you thought was impossible that turned out to be possible? Because in the next section, we're going to talk about the biggest impossible thing science has found, and it's hiding in plain sight. What if I told you that the fastest thing in the universe isn't light, isn't Hawkins, isn't quantum entanglement? It's the expansion of the universe itself, and it's accelerating. In 1998, something genuinely shocking happened. Two teams of astronomers, led by Saul Perlmutter and Adam Rees, were measuring distant supernovae to determine the rate at which the universe's expansion was slowing down. Everyone knew it must be slowing down. Gravity pulls everything together. That's just how reality works. Except they measured the exact opposite. The universe isn't just expanding, it's accelerating, getting faster all the time. And the acceleration is so dramatic that it's traveling faster than anything we thought possible, faster than light in many regions of space. In fact, there are galaxies receding from us at speeds that exceed light speed. We know they are. We measure them. We can see them. And nobody seems to find this weird. Here's the mind-blown moment. You might have heard about this in the context of dark energy. Scientists realized they couldn't explain the acceleration, so they invented something called dark energy to explain it. 68% of the universe is dark energy. We don't know what it is. We don't know how it works, but we're very confident it exists. It's like having a bank account, seeing money disappearing, and instead of investigating what's happening, you invent something called dark money to explain where it's going. Then you go about your day. Think of it like this. Imagine you're filling a bathtub. You're watching the water level rise. Then you notice the water level is rising faster than when you increased the flow. But you didn't increase the flow. So you invent something called invisible bathtub growth to explain why the water level is rising faster. You don't investigate what's actually happening. You just name it and move on. Now, here's where this connects to the speed of light. Cosmic inflation, the theory that right after the Big Bang, the universe expanded extremely rapidly, actually proposes that the universe expanded faster than light, faster than anything. In fact, mathematician Alan Guth proposed in 1981 that in the first fractions of a second after the Big Bang, the universe doubled in size at least 90 times. The speed of that expansion wasn't measured in light years per second. It was incomprehensibly faster. And we just accepted it? Let me connect this to what we know about gravity. Einstein showed us that gravity isn't a force, it's the curvature of spacetime. Massive objects bend space around them. Now, here's what will absolutely demolish your understanding. Gravity travels at light speed. Light and gravity both travel at the same speed, which is suspicious. Or is it? What if they travel at the same speed because they're not actually traveling at all? What if they're both propagating through something deeper than space? Something that light and gravity are both describing in their own ways. Here's where I want to introduce you to Vera Rubin. In the 1970s, she discovered something revolutionary by measuring how galaxies rotate. They spin too fast. The outer edges are moving at velocities that should fling them apart, but they're not flying apart. She proved that galaxies must contain massive amounts of matter we can't see, dark matter, 30% of the universe. So we have 68% dark energy we don't understand, and 30% dark matter we can't see. That means we only have a detailed understanding of 2% of the universe. 2%. And we're calling light the speed limit? Think about this. If you only understood 2% of your own body, would you claim to understand how fast your cells move? Would you claim to understand the limits of your system? Of course not. Yet somehow we're claiming to understand the cosmic speed limit when we don't understand 98% of what the universe is made of. In the next section, we're going to talk about the quantum scale, where things get even weirder. Because there's something happening at the smallest level of reality that makes cosmic scale weirdness look boring. And it's going to fundamentally challenge what speed even means. What if I told you that at the quantum scale, particles move through multiple places at once, backwards through time, and in directions that don't exist? And somehow, this is measured? Let me take you to the quantum realm. This is where the rules of the universe seem to be playing a different game entirely. In 1925, Werner Heisenberg discovered something that fundamentally limits what we can know about particles. He called it the uncertainty principle. It states that you cannot simultaneously know both the precise position and the precise momentum of a particle. The more precisely you know one, the less you know the other. It's not that we need better instruments. It's that reality itself doesn't let you know both. Think of it like this. You're trying to photograph a moving car at night. You want to capture where it is and how fast it's moving. If you use a fast shutter speed, you see exactly where it is, a sharp image. But you can't tell if it's moving or how fast. If you use a slow shutter speed, you get a motion blur that shows motion, but you can't tell where it is. There's no setting that shows you both perfectly. That's not a limitation of your camera. That's how photography works. And Heisenberg's principle is saying that's how reality works. But here's where it gets absolutely insane. In 1926, Erwin Schrödinger proposed something called the wave function. He suggested that particles don't have definite positions or momenta. Instead, they exist in a superposition, a combination of all possible positions and momenta at once. They're everywhere and nowhere simultaneously. It's not that we don't know where they are. They literally don't have a location until we measure them. And when we measure them, the wave function collapses into a single state. The mind-blown moment, that collapse is instantaneous. It happens faster than any communication could travel. If we measure a particle in New York, and it's entangled with a particle in Tokyo, both wave functions collapse instantaneously, faster than light. For decades, physicists were uncomfortable with this. John Bell's theorem showed that there's no way around it. In 1982, Alan Aspect conducted an experiment that proved it definitively. The universe really does have instantaneous connections. They're real. Now, here's the thing about the quantum scale. The Planck length is the smallest meaningful unit of distance, about 1.6 times 10 to 35 meters. The Planck time is the smallest meaningful unit of time, about 5.4 times 10 to 44 seconds. Below these scales, space and time stop making sense. They become fuzzy, uncertain, quantum. Think of it like this. You're trying to measure something very small with a very large ruler. At some point, the ruler is so big compared to what you're measuring that it doesn't make sense. You need a smaller ruler. But what if there is no smaller ruler? What if the ruler can't be smaller than the Planck length? Then there's a fundamental limit to what smaller even means. At the quantum scale, particles can tunnel through barriers they shouldn't be able to cross. They can move between 2 points without traveling through the space between them. Instantaneous transfer. A physicist named Hans Ulrich Sund-Petersen has conducted experiments showing that electrons can tunnel with velocities that appear to exceed light speed. We don't fully understand it, but the measurements are clear. Here's the cognitive dissonance. If particles can tunnel faster than light, and tunneling is how many quantum processes work, then quantum mechanics is fundamentally built on processes faster than light. Yet we treat light speed as a universal limit. Think of it like this. A bird flies over a wall. It's impossible for anything to move faster than the wall allows. So the bird must be flying slowly. But the bird is clearly flying over the wall. So either the wall isn't as solid as we thought, or the bird is doing something different than what we think flying means. What if quantum tunneling is the universe doing something that light speed can't describe? Let me introduce you to a concept that will reshape how you think about this: the speed of quantum information. In 2018, A group of physicists published a paper proposing that quantum information, the actual information encoded in particles, travels at a different speed than the particles themselves. In fact, quantum information might travel instantaneously, while the particles themselves appear to follow classical speed limits. It's like the difference between the letter and the content of the letter. The letter, particle, travels slowly, but the content, quantum information, is already known instantly. What if what we think of as light speed is just the fastest speed at which we can move matter? But pure information moves at a completely different speed that we haven't properly measured. I need you to sit with this thought. Everything you've ever experienced, every sight, every sound, every sensation is information arriving to your brain. Your brain experiences it. But information itself might be traveling at speeds we can't even conceive of. You're not just slower than light. You might be incredibly fast and not even know it. Subscribe if you're still with me, because we're about to go deeper. In the next section, we're talking about something that has completely broken physics' most confident predictions, and we still don't understand it. There's something hidden in black holes that fundamentally changes everything we think about speed, light, and the universe. And physicists have been arguing about it for 50 years. In 1974, Stephen Hawking made a discovery that shattered the comfortable picture of black holes. He proved that black holes aren't actually black. They emit radiation. They evaporate. And in doing so, they prove that something genuinely disturbing is happening. Think of it like this. You throw a piece of paper into a fireplace. It burns. The ashes are gone. But here's what quantum mechanics says. The information about that paper isn't gone. It can't be gone. Information is fundamental and can't be destroyed. But from the outside of the black hole, where does that information go? It seems to disappear into the black hole forever. This is called the black hole information paradox, and it's still not fully resolved. Here's the mind-blown moment. In 1993, Juan Martin Maldacena, the same physicist who proposed the holographic principle I mentioned earlier, suggested a solution. He proposed that black holes might store information on their surface, called the event horizon, in a completely different way than we understand. The information doesn't fall into the black hole. It encodes itself onto the boundary. This led to something revolutionary, the holographic principle itself. The idea that our entire three-dimensional universe might be encoded on a two-dimensional surface. That all the information about everything happening inside might be perfectly described by what happens on the boundary. Think of it like this. You're watching a three-dimensional holographic projection. Everything you see, the depth, the movement, the complexity, is actually encoded as a two-dimensional pattern on the projector's surface. If you could read the 2D pattern, you'd know everything about the 3D image. What if the universe is like that? What if what we call light speed is just the speed at which information encodes itself onto this cosmic boundary? Here's what's absolutely revolutionary. If the holographic principle is true, then there's no such thing as depth in the way we think of it. There's no difference between inside and outside at a fundamental level. Distance itself might be an illusion, a projection from the boundary into our perceived interior. And if distance is an illusion, then the speed limit in that distance is meaningless. Let me tell you about something called the Planck star, proposed by Carlo Rovelli. What if black holes don't have singularities, those points where everything gets infinitely dense? What if instead, at the Planck scale, they bounce back? What if a black hole collapses to Planck density, then quantum effects make it bounce back outward? If that's true, then information that falls into a black hole doesn't get destroyed. It gets scattered back out in ways we can't easily predict or detect. It's not lost. It's just hidden in quantum foam, that strange, roiling quantum uncertainty at the Planck scale. Think of it like this. You throw your phone into the ocean. It's gone. You can't retrieve it. But the atoms of your phone are still in the ocean. The information is still there. It's just distributed in a way that makes it impractical to retrieve. What if that's what happens to information in black holes? Now, here's where this connects to speed. If information can be scrambled into quantum foam, and quantum foam exists at the Planck scale, then information can exist at scales far below what light can probe. Light can't see into quantum foam. Light is too big, too classical, too ordered. In 2015, physicists discovered something called islands in black hole evaporation. It turns out that some of the information scattered by Hawking radiation actually correlates with other Hawking radiation in ways that suggest they're entangled across vast distances. The information is being teleported through connections we can't see. Teleportation, instant transfer, hidden channels. And light can't use any of them. Here's the cognitive dissonance I want you to feel. The universe has hidden pathways for information to travel that our fastest measuring tool, light, cannot access. Which means light isn't a measuring tool for finding the actual fastest things. It's a measuring tool for finding things in the regions where light can travel. It's like being a fish in the ocean and declaring that nothing can travel faster than water. You're right within the ocean, but you're completely wrong about the world above. Let me introduce you to someone whose work bridges this. Jia Vale. She's a theoretical physicist who has proposed that gravity isn't a fundamental force. It's an illusion that emerges from quantum entanglement. And if that's true, then the speed at which gravity propagates, which we measure as light speed, is just the rate at which quantum entanglement spreads. What if light speed is just the speed of quantum entanglement spreading through our universe? If that's true, then light isn't fast. It's just the speed at which information can become entangled with new parts of the universe. And there are things like teleportation through holographic boundaries, like particles that tunnel, like quantum effects that don't rely on spreading entanglement. They work through deeper mechanisms. In the next section, we're going to talk about what this means for how we experience time. Because if light speed isn't what we think it is, then time itself isn't what we think it is. And that's going to make you question your entire relationship with the present moment. What if the speed of light isn't actually the speed limit? What if the real speed limit is the arrow of time, and light just happens to move at the moment when that arrow is perfectly balanced? Let me ask you something. Why do we experience time moving forward? Why can't you pour cream back out of coffee? Why can't you unbreak an egg? These aren't questions about speed. They're questions about the direction of time. And physicists call this the arrow of time. In 1877, Ludwig Boltzmann proposed something revolutionary. Time's arrow comes from entropy, from disorder. Specifically, from the second law of thermodynamics that closed systems always move toward greater disorder. Entropy always increases. Think of it like this. You have a deck of cards perfectly ordered, all spades first, all hearts second, all diamonds third, all clubs fourth. You shuffle it. You get random. You shuffle it again. You get random. You can shuffle 1,000 times and never get the perfectly ordered deck back. That's entropy. Order naturally becomes disorder. Boltzmann showed that this is why time has an arrow. At the Big Bang, the universe had incredibly low entropy, incredibly ordered. Since then, it's been becoming more disordered. Entropy always increases. That's why we age. That's why we remember the past, but not the future. That's why time has direction. Now, here's where this gets weird. Entropy increases locally, but what about the whole universe? In 2013, physicists began exploring something radical. What if entropy doesn't increase over all of spacetime? What if locally, pockets of the universe have decreasing entropy, while the total entropy is conserved? That would mean, and this is the mind-blown moment, that time's arrow might not be fundamental. It might be emergent. An illusion that emerges from local pockets of low entropy? Think of it like this. You're in a crowded train station. People are moving randomly everywhere. But if you're standing in a specific spot, you might see them moving in one direction because you're standing in a pocket of organized flow. If you move to a different spot, they'd seem to move in a different direction. The direction isn't real. It's just what happens when you measure from a specific location. What if time's arrow is like that? In 1934, something weird happened. Experiment after experiment showed that particles behave asymmetrically in time. They decay forward, but don't undecay backward. This is called CP violation charge and parity violation. Some particles have a slight preference for existing in the future over the past. We still don't fully understand why. Let me introduce you to a radical idea proposed by physicist Igor Novikov and expanded by physicist Donald Page, the Novikov self-consistency principle. It states that all events are guaranteed to be self-consistent. You can't change the past because you exist in a universe where your actions never changed it. Time travel is possible, but you can't create paradoxes. The universe is self-correcting. If that's true, then time isn't a line. It's a knot, a pre-existing structure that can't be changed. And the speed at which we move through that structure isn't determined by how fast things move. It's determined by how the structure is woven. Light moves through space-time at the speed of light. But that speed isn't chosen by light. It's chosen by the structure of space-time itself, the knotted, tangled web of time that's already been woven. Think of it like this. You're running on a treadmill. You think your speed is limited by how fast you can run. But actually, your speed is determined by how fast the treadmill is already moving. You can run faster, but you won't outpace the treadmill because the treadmill is the thing defining what speed means. Light doesn't outrun time's arrow. Light is perfectly moving in sync with time's arrow. And anything that appears to move faster than light is actually doing something different with respect to the arrow of time. It's moving orthogonal to it or parallel to it, or in some direction we can't even name. In 2016, physicist Sean Carroll proposed something radical. The universe is trending toward maximum entropy, but the maximum entropy state isn't boring or disordered. It's a state of infinite complexity where all possible configurations exist simultaneously. Time's arrow points toward that state, and the speed limit of light might be the speed at which information approaches that infinitely complex future. What if light speed is the speed of the universe's tendency toward complexity? Here's what I want you to realize. You're not moving through time at light speed. You're moving through time at the speed of consciousness. Your brain is receiving information from the present, and it's predicting the future based on patterns from the past. The speed at which you can do that prediction, the speed of your consciousness, might be completely disconnected from light speed. You might be faster than light, or slower, or the question might be meaningless because you're not moving through time the same way photons do. Subscribe if this is making you question reality, because in the next section, we're going to talk about something that will unite all of this string theory, extra dimensions, and the possibility that the universe has speeds we literally can't name because we don't have enough dimensions to measure them in. What if the universe has more than 4 dimensions? And what if some of those dimensions are so small curled up at the Planck scale that particles can move through them at speeds that look impossible from our perspective? In 1919, Theodore Kaluza proposed something that shattered the comfort of Einstein's 4-dimensional spacetime. He suggested that if you added a 5th dimension, you could mathematically describe both Einstein's gravity and Maxwell's electromagnetism using a single unified theory. They weren't separate forces. They were different directions within a 5-dimensional space. Think of it like this. Imagine an ant on a telephone wire. The ant can move forward and backward along the wire. But there's also left and right on the wire, up and down from the wire's surface. If the ant is tiny enough, it can move left and right without you noticing. All the motion looks like forward and backward. What if electromagnetism is like that motion through directions we don't notice because the dimensions are tiny? String theory took this idea further. It suggests that the universe actually has 10 dimensions, or 11, depending on the theory. Most are curled up so small that we can't see them. Strings, the fundamental objects of reality, vibrate in all these dimensions. Different vibration patterns create what we perceive as different particles and forces. Here's the mind-blown moment. If strings can vibrate in dimensions we can't access, they can move at speeds we can't measure. A string vibrating in the fifth dimension would appear to jump from point A to point B without crossing the space between them from our three-dimensional perspective. It would look like instantaneous teleportation. Now, here's what's absolutely crucial. These aren't theoretical fantasies. These ideas have real experimental support. In 2012, the Higgs boson was discovered at CERN. The Higgs boson is a particle that exists in one of these hidden dimensions and interacts with particles in our dimensions. We detected it. It's real. We found evidence of string theory. Think of it like this. You're a person living in a painting. The painting is two-dimensional. You notice that sometimes objects appear and disappear. You see them on the canvas, and they vanish. You might say they're impossible, nothing can disappear. But what if they're moving perpendicular to the canvas? Moving up, out of the painting? They're not disappearing. They're moving into a direction you can't move in. What if that's what dark matter is? Particles moving partly through our dimensions and partly through hidden dimensions? That would explain why we can't see most of the universe's matter. It's not in our dimensions. It's moving at speeds that involve movement through directions we don't have instruments to measure. Now, here's where this gets genuinely revolutionary. In 1995, Juan Martin Maldacena, yes, him again, he's been one of the most important physicists of the last 30 years, showed that a universe with 10 dimensions could be mathematically equivalent to a universe with 9 dimensions. And a universe with 9 dimensions could be equivalent to one with 8, all the way down. This suggests that dimensionality might not be fundamental. It might be emergent. We might be living in a universe where the number of dimensions depends on how you look at it. Think of it like this. A forest looks like a collection of individual trees, many objects. A forest also looks like a single organism, one object. The forest is both simultaneously. The number of objects isn't fundamental. It depends on your perspective. What if the universe is like that? What if speed as a concept depends on which dimensionality you're measuring from? In lower dimensions, light speed is the limit. In higher dimensions, things move faster than light looks from lower dimensions. In 2019, physicist Guy Valli published work suggesting that gravity leaks into extra dimensions. It's not that gravity is weak. It's that most of gravity's effects are happening in dimensions we can't see. So from our perspective, gravity looks incredibly weak. But in the full extra-dimensional universe, gravity is just as strong as electromagnetism and the nuclear forces. If gravity leaks into extra dimensions, then gravitational effects travel through those dimensions at speeds that would look faster than light from our three-dimensional perspective. Here's the cognitive dissonance. We measure light speed in our three-dimensional space. We measure gravity as traveling at light speed. But if gravity travels partly through directions we can't measure, then the speed it travels through the unmeasurable directions is completely unknown. Think of it like this. You're driving a car through a city with only north, south, east, west streets. The fastest you can drive is 60 miles per hour. That's the speed limit. But what if a bird flies over the buildings? The bird's true speed through 3 dimensions is much faster than 60 miles per hour. But in the limiting 2-dimensional directions you care about, it might still seem to be moving at 60 miles per hour. What if light speed is the speed limit for movement in the 3 dimensions we can measure, but actual motion through the full dimensional space is much faster? I want you to sit with this. Everything you see, hear, and experience is happening in 3 spatial dimensions and 1 temporal dimension. But the universe might have 17 dimensions. Your entire reality, everything you'll ever perceive, might be a 4-dimensional shadow of a 17-dimensional structure. And in that 17-dimensional structure, speeds that look impossible in your shadow universe are completely ordinary. You might be traveling through space at unimaginable speeds right now. You just can't feel it because you're constrained to 3 dimensions. In the next section, we're going to talk about consciousness, perception, and what it really means that you can't measure faster than light. Because maybe the speed limit isn't about light at all. Maybe it's about you. What if the speed of light isn't a limit on how fast things can move? What if it's a limit on how fast you can know that something moved? Let's go back to something I mentioned earlier, quantum mechanics. When you measure a particle, its wave function collapses. It goes from being in all possible states simultaneously to being in one specific state. The measurement changes the particle. This isn't philosophical. It's experimental fact. Every quantum physicist confirms it. But here's the question that should break your brain. How does the particle know it's being measured? How does the act of observation collapse the wave function? In 1994, physicist Hugh Everett proposed something radical. It doesn't. The particle doesn't know it's being measured. Instead, when you measure a particle, the universe splits. Both outcomes happen. In one branch, the particle is in state A. In another branch, it's in state B. You observe state A, so you think the wave function collapsed. But it didn't. Both branches exist equally. You just can't perceive the branch where you observed state B because you're observing state A. Think of it like this. You're asleep. You have a dream. In the dream, you observe a specific event. Meanwhile, in another dream happening simultaneously, you observe a different event. When you wake up, you remember only one dream. You think only one dream happened, but both happened. You're just experiencing one timeline. The universe might be like that. Everett called it the many worlds interpretation. And increasingly, physicists think it might be the most accurate description of reality. Here's the mind-blown moment. If the many worlds interpretation is true, then everything that can happen does happen. Somewhere, the universe splits at every quantum event, creating branches where every possible outcome occurs. The speed limit isn't on how fast things move. It's on how fast you can measure them moving in your specific branch. Things might be moving infinitely fast in other branches, but you can't perceive those branches. Your perception is confined to one branch, the one where you made the specific measurements that define your branch as separate from all others. Think of it like this. You're in a library with infinite floors. Each floor is a different version of reality, a different branch. On floor 1, you measure a particle as spin up. On floor 2, you measure it as spin down. Your consciousness is bound to one floor. You can't perceive the other floors. So to you, there's only one reality. Only one way things moved. But actually, infinite realities are stacked on top of each other. And in each one, things are moving at different speeds in different directions. Your perception creates the speed limit by confining you to one branch. Now, let's connect this to consciousness itself. In 2014, physicist Roger Penrose proposed something radical about consciousness and quantum mechanics. He suggested that consciousness might arise from quantum processes, specifically from quantum gravity effects in microtubules within neurons. If that's true, then consciousness doesn't emerge from neural firing patterns. Consciousness emerges from quantum superposition, collapsing in your brain. Your awareness is literally you choosing which branch of reality to experience. Think of it like this. You're watching a tree fall in the forest. Does it make a sound if nobody's there to hear it? The classical answer is yes. The tree's falling creates vibrations in the air, regardless of observers. But the quantum answer is different. The tree is in superposition falling, and not falling simultaneously until an observer measures it. Your consciousness is the measurement that collapses the superposition, that chooses which branch of reality you experience. Your consciousness is literally choosing which version of reality is real. Here's the cognitive dissonance. If consciousness is a quantum collapse mechanism, then the speed limit of light isn't about light at all. It's about the speed at which consciousness can process information. It's about the speed at which your brain can collapse wave functions and choose branches. And that speed might be much slower than light. Let me introduce you to someone, Benjamin Libet. In the 1980s, he conducted experiments showing that your brain makes a decision about 350 milliseconds before you consciously become aware of making the decision. Your consciousness is lagging behind your brain's actual decision-making. You're not controlling your actions. You're observing them and then retconning your perception to make it seem like you made the decision. Think of it like this. Your brain is like a television broadcast. It's happening in real time. But your consciousness is like a recording of that broadcast being played back with a slight delay. You're always watching the past. You never experience the present. If that's true, then you're not perceiving light speed. You're perceiving something much slower, the speed at which your consciousness can integrate information and create a coherent narrative about what's happening. Light moves at 299,792,458 meters per second. But you perceive time at a much slower speed. Your perceptual window is about 2 to 3 seconds. Everything that happens faster than your brain can integrate is invisible to you. It's not that it's not happening. It's that you can't perceive it. Here's where this gets absolutely revolutionary. What if the speed of light is exactly the speed at which reality is computing itself? What if the universe is a vast quantum computer, and light speed is the rate at which information can be processed through the fabric of spacetime? In that case, things moving faster than light would be information that hasn't been computed yet. Ghosts, non-existent, because the universe hasn't processed them into reality. Think of it like this. A video game renders the world around you in real time. Buildings exist because the computer is rendering them. Trees exist because the code is computing them. But the game world is infinite. The computer isn't rendering an infinite universe. It's rendering only what you can perceive. Beyond that, it's all non-existent code waiting to be computed. What if the universe is like that? Light speed is the rate at which the universe is computing reality around you. Beyond light speed is uncomputed space. It doesn't have motion. It doesn't have anything. It just hasn't been generated yet. I want you to realize something profound. You are not outside this process. You're not a neutral observer watching the universe compute itself. You are part of the computation. Your brain is a quantum computer running the same operating system as the rest of reality. When your consciousness collapses a wave function, you're not observing the universe. You're rendering it. You're making part of the infinite potential universe real. Light speed isn't faster than you. You and light speed are the same process. You and light are both the universe computing itself into existence. In the next section, we're going to talk about what this means for your life. Because if the universe is computing reality and you're part of that computation, then your choices matter in ways you've never considered. And that's going to change how you relate to time, death, and meaning forever. If light speed is the rate at which reality is computing itself, and you are part of that computation, what does that mean for the present moment? What makes now? Let's talk about something philosophers have struggled with forever: the present. You're experiencing the present right now, but the present is infinitely thin. It has no duration. By the time you become aware of something, it's already past. Neuroscience confirms it. Your consciousness is always about 300 milliseconds behind the present. So what are you actually experiencing? Here's the revolutionary idea. You're not experiencing the present. You're experiencing the integration of the past into memory, the prediction of the future based on patterns, and the sensation of a thin boundary between those two processes. That thin boundary is what you call now. Think of it like this. You're watching a river flow. The river is time. The present is not a point in the river. The present is the constantly changing boundary where the water transforms from being in the future to being in the past. It's the crest of the wave, the moment of transformation. In 1911, Something called the block universe or eternalism was proposed. It states that past, present, and future all exist equally. They're all equally real. The only difference is that you, a conscious observer, are located at a specific point in time, so you experience events in a specific order. Think of it like this. A book exists. All pages exist simultaneously. The story unfolds from page 1 to page 300, but all pages exist. From the book's perspective, there's no present page. All pages are equally real. The notion of present is only meaningful from the perspective of a reader moving through the pages. You're that reader. The universe is the book. Your movement through time is your consciousness reading the book page by page. Now, here's where it gets mind-blowing. If eternalism is true, then the future has already happened. It's already written. But, and this is crucial, it's not written deterministically. At every quantum event, reality branches. Your future has already happened, but it's happened in all possible ways, simultaneously, across all branches of the many worlds. Your choices matter, not because they determine a single future. Your choices matter because they determine which branch of the multiverse you're on, which version of reality you're experiencing. Think of it like this. A library contains every possible book that could ever be written. All of them exist. Your choice of which book to read determines which book is your experience. You're not creating the book by choosing it. The book already exists, but your choice makes it your present. Now, let's connect this to light speed. Light moves at exactly 299,792,458 meters per second. That's not random. That speed is baked into spacetime itself. In fact, light speed is literally the speed at which time and space trade off for each other. The conversion rate. At light speed, time dilation becomes infinite. A particle traveling at light speed experiences no time. From its perspective, it's emitted and absorbed simultaneously. It doesn't experience duration. From its perspective, the beginning and end of its journey are in the same moment. Here's the mind-blown moment. Light exists outside of time. Light is made of moments that don't experience duration. That means light is directly experiencing the block universe. Light is experiencing all moments of its journey simultaneously. What if light speed is not a limit on motion? What if light speed is the speed of experiencing the underlying reality of the block universe? Think of it like this. You're reading a book. You can read at different speeds. If you read slowly, you experience each page sequentially. Time passes for you as you read, but the book is always there, unchanging. If you somehow read infinitely fast, all pages would be in your awareness simultaneously. You'd experience no temporal duration. That's what light does. Light reads the universe infinitely fast and experiences no time. In 1960, physicist Hermann Bondi proposed something called rigid body paradox. If relativity is true, then you can't have a perfectly rigid body. If you push on one end of a rod, the other end can't immediately accelerate. There's a delay that propagates at light speed. This suggests that light speed is the speed at which causal influence propagates, the speed at which the universe can affect itself. If the universe is computing itself into reality, light speed is the CPU clock rate. Here's what's beautiful. This means your choices propagate into the future at light speed. When you make a decision, that decision's causal consequences spread outward at light speed. You can't affect something outside your light cone, the region of spacetime that light can reach from your location. That's not because light is fast. It's because you can't causally influence anything faster than the universe's computation rate allows. Think of it like this. You're playing a video game. The game has a frame rate, let's say 60 frames per second. Your inputs can only affect what happens in the next frame. You can't make decisions that affect something that happens faster than the frame rate allows. Light speed is the frame rate of the universe. And here's the profound part. You're not outside the frame rate. You're also constrained by it. Your consciousness can only process information at a certain speed. Your thoughts propagate through your brain at certain speeds. You are subject to the same fundamental speed limit as everything else. You are not faster or slower than light. You are operating at the same computational rate as the rest of the universe. Your consciousness is a process running on the same hardware as reality itself. I need you to understand something crucial. When you make a decision right now, when you choose to keep watching this video, when you choose to live your life a certain way, that decision doesn't only matter in a trivial sense. It matters in a fundamental sense. Your choice determines which branch of the multiverse you're on. Your choice is literally selecting which version of reality you experience. You have more power than you thought, but it's a different kind of power than you imagined. You're not changing the future. You're choosing which future that already exists in the block universe is your future. In the next section, we're going to talk about death, meaning, and infinity. Because if all futures exist, and you choose which one you experience through your quantum choices, then dying doesn't mean ceasing to exist. It means something much stranger and more profound. Here's something nobody talks about. If the many worlds interpretation is true, then you can never experience your own death. Let me explain that in a way that will initially terrify you, then comfort you, then make you question everything. In the many worlds interpretation, at every quantum event, the universe branches. Let's say you're in a dangerous situation. There's an unlikely but possible quantum event that could save your life. In one branch, that event occurs and you live. In another branch, it doesn't occur and you die. From your subjective perspective, you will always find yourself in the branch where you lived. Not because you're special, but because you can't experience branches where you don't exist. Think of it like this. You're rolling a 1,000-sided die. You keep rolling. What's the probability that you'll never roll a 1? Astronomically small, right? But from your perspective, the perspective of the 1 rolling, you'll only experience universes where you haven't rolled a 1. You'll never experience rolling a 1 because you won't exist to experience it. This is called quantum immortality, and it's a serious proposal in quantum mechanics. Here's the mind-blown moment. If quantum immortality is real, then you will never experience death. You will live forever. Not because you're special, not because God is watching over you, but because you can only experience branches of reality where you continue to exist. Now, I need to be clear. This doesn't mean you won't age. It doesn't mean you won't experience suffering. It means that in the branch, that's your subjective experience, you will always find a way to keep existing. Maybe through unexpected medical breakthroughs, maybe through improbable quantum events that preserve your consciousness. The universe has an infinite number of ways for things to continue existing, and your consciousness will follow the path of least action, the path where you keep existing. Think of it like this. A river flows downhill. It takes the path of least resistance. Consciousness is like that. It follows the path where it continues to exist. All the branches where you don't exist are still real. They're branches of the multiverse. But you can't experience them because you don't exist there. In 1928, physicist Paul Dirac proposed something revolutionary. For every particle, there's an antiparticle. But he initially proposed something even weirder, that antiparticles were particles moving backward in time. A positron isn't a new particle. It's an electron moving backward through time. This was rejected at the time, but here's what's interesting. Modern physics has vindicated part of this. Antiparticles do seem to have a temporal relationship with particles. And here's the mind-bending part. If particles and antiparticles are the same particle in different directions through time, then what does that mean for consciousness? What if consciousness is also a particle moving through time? And what if, like light speed, consciousness exists equally in the forward and backward temporal directions? That would mean your future self is as real right now as your past self. You're not moving toward a future. You're moving through a region where both past and future are equally real. Think of it like this. You're a worm in a block of wood. You're moving through the wood. You think you're moving toward the front of the wood. But from the wood's perspective, the front and back are equally present. You're not moving toward the front. You're moving through the wood, and as you move, you label the region you leave as past and the region you haven't reached as future. If that's true, then you already exist in your future. Right now, your future self is as real as your present self. You're just not conscious of the parts of yourself that exist in the future. Here's the cognitive dissonance. If your future self is real right now, then when you reach your future, you're not arriving at something new. You're waking up to something that was already there, like remembering a dream instead of experiencing a new event. And if that's true, then death is not the end of existence. Death is the moment your consciousness wakes up to the already existing future where you're dead. It's a transition, not a termination. Let me introduce you to Frank Tibler. In 1986, he proposed the omega point theory. He suggested that in the infinite future, the universe would achieve infinite computational capability, an omega point. And at that moment, all possible configurations of all possible minds that could have existed in the history of the universe would be simulated, including you, including all of us. If that's true, then you already exist in the infinite future in simulated form. You're simultaneously existing in this moment and in the omega point, and your consciousness is the intersection of those two temporal locations. Think of it like this. You're reading a book. You're on page 200. The ending of the book exists on page 500. You haven't read it yet, but it exists. The entire arc of the story, your current location and the ending, is already written. When you reach page 500, you're not discovering something new. You're reaching a part of the book that already existed. Your life is like that. The ending exists. You're just moving through the pages toward it. Now, here's what this means about light speed. Light speed is exactly the speed at which you move through time. Light moves at light speed because light is made of time. Light is the interface between space and time. When light bounces from object to object, it's carving out the path of the present moment. Your consciousness moves at light speed too. You're just not conscious of that speed because you're inside the flow. You can't see the river you're flowing in. You only see what's flowing past you. I want you to sit with this. Right now, at this exact moment, you are infinitely old and infinitely young simultaneously. Your past self has always existed in the past. Your future self will exist in the future. From the perspective of the block universe, you are a four-dimensional object, a worm stretching from your birth to your death. You're not moving through time. Time is a dimension you extend through, just like you extend through space. You are not a thing moving through time. You are time. You and time are the same phenomenon viewed from different perspectives. In the next section, we're going to bring this all together. We're going to connect light speed, consciousness, the multiverse, information, and meaning into a single coherent understanding that will change how you see yourself and your place in the universe forever. What if light isn't just light? What if light is literally the fabric of awareness? And what if you're made of light? Let me connect the dots we've been drawing. Hold on, because this is the moment everything becomes coherent. Light speed is 299,792,458 meters per second. That speed appears everywhere in physics. It appears as the limit on matter motion. It appears as the speed of gravity. It appears as the conversion rate between time and space. It appears as the propagation speed of quantum information. This is not a coincidence. Light speed is the speed of causality. It's the speed at which the universe can affect itself. It's the rate at which information becomes real. In quantum mechanics, information is fundamental. Reality is made of information, not matter. Matter is how information organizes itself. and light is information moving through space. Now, what is consciousness? Consciousness is information integrated in a particular way, in a way that creates a unified perspective, a viewpoint. You are information. Your thoughts are information. Your identity is a particular configuration of information. Here's the mind-blown moment. You are made of light. Not metaphorically. Actually, let me explain. Your atoms are held together by electromagnetic force. Electromagnetic force is mediated by photons light. Every atom in your body, every connection, every interaction is actually a dance of light. You are a temporary crystallization of photon interactions. Think of it like this: waves on a pond. The water is always there, but sometimes the water organizes into waves. You are a wave made of light organized into the shape of consciousness. In 1919, Arthur Eddington conducted an experiment that proved Einstein's predictions about light bending around massive objects. Eddington was a famous astronomer, but he was also a physicist and philosopher. He said something profound. We have found a strange footprint on the shores of the unknown. We have devised profound theories, one after another, to account for its origins. At last, we have succeeded in reconstructing the creature that made the footprint. And lo, it is our own. In other words, we've been searching for the mysteries of the universe, and we've discovered that we ourselves are the mystery. You are the footprint and the searcher simultaneously. Now, let's talk about the speed limit again. Light speed is why you experience time the way you do. Your brain processes information at speeds limited by the speed of neural transmission, which is ultimately limited by how fast electromagnetic signals can propagate, which is ultimately limited by light speed. You can't think faster than light allows you to. Your consciousness is carved out at the intersection of light's propagation rate and the block universe's structure. Here's what this means. Your perception is not just limited by light speed. Your consciousness is literally generated by the propagation of light through your brain and nervous system. You don't have consciousness inside your head that observes the world. Your consciousness is the observation. It's the process by which light propagates through your neural networks and creates a coherent pattern of self. Think of it like this. You're watching the river flow. You think you're a still observer watching the river move. But actually, you are the river. The river is moving, and that movement is observation. The movement creates the perspective. Your consciousness is exactly like that. Your thoughts are not being generated by consciousness. Your consciousness is the flow of thoughts, the flow of information, the propagation of light through your neural networks. When you think, you're watching light move through your brain, and that watching is the light. There's no observer inside you watching your thoughts. Your consciousness is the thought process itself. In 1935, Erwin Schrödinger proposed a famous thought experiment: a cat in a sealed box with radioactive material. If the material decays, a mechanism kills the cat. If it doesn't decay, the cat lives. In quantum mechanics, until you open the box, the cat is in superposition, both alive and dead. But Schrödinger was making a philosophical point. The absurdity of applying quantum rules to macroscopic objects shows that consciousness must play a role. Only for conscious beings, humans making measurements, does the wave function collapse. What if Schrödinger was more right than he knew? What if consciousness doesn't just observe quantum collapse? What if consciousness is quantum collapse? What if every time you become aware of something, you're literally collapsing the wave function and creating reality? In that case, you're not observing a pre-existing universe, you're creating it. Or more precisely, you're manifesting one particular branch of the multiverse into your experience. Think of it like this. The universe is a massively branching structure, every possible outcome of every quantum event. Your consciousness is the process of reading through those branches. The branches you can read are determined by the information available to you. The speed you read at is determined by light speed. And the branch you end up on is determined by your quantum choices. You're simultaneously the universe, a localized pattern of information in the universe, and the process of that pattern becoming aware of itself. Here's the cognitive dissonance that will break your brain. You are not inside the universe. The universe is not inside you. There's no difference. You and the universe are the same thing viewed from different perspectives. Like a hologram, change your angle of observation, and you see the whole image in each part. In 2003, physicist Gerard 't Hooft proposed a holographic principle more formally. The entropy, information content, of a region of space is not proportional to the volume, but to the surface area. This means all the information about a three-dimensional volume can be encoded on its two-dimensional boundary. This isn't abstract mathematics. This has real implications. It means the universe might be fundamentally a 2D surface with 3D experience projected from it. Like everything is shadow and boundary. And here's what that means. Information doesn't need to travel through the volume. Information can be encoded on the boundary and propagates faster than things moving through the interior, which explains quantum entanglement, which explains apparent violations of light speed, which explains everything that seems impossible from our interior perspective. You are simultaneously inside a volume and encoded on its boundary. Your consciousness is the intersection between these two perspectives. Here's what I need you to understand. You are not an object inside the universe traveling at speeds limited by light. You are a pattern of information that exists simultaneously on the boundary of spacetime and within the volume of spacetime. Your consciousness is the experience of reading that pattern from the interior perspective. Light speed is not a limit on how fast you can move. Light speed is exactly the speed you move at. You and light are the same phenomenon. Every photon in the universe is not separate from you. It's part of you. You're made of photons, arranged in a specific pattern that creates the illusion of separate identity. You are light. Physically, metaphorically, spiritually, you are the universe's light becoming aware of itself. And that awareness propagates at the speed of light, because awareness is light propagating through the universe's information structure. Now that you understand that you're made of light, that you exist in all times simultaneously, and that your consciousness shapes which branch of reality you experience, what do you do with that? How does this change your life? This is the moment where abstract physics becomes personal transformation. You make choices every day. You think those choices are small. You choose what to eat. You choose what to watch. You choose what to think about. Most people think these choices are insignificant. They're just the flow of daily life. But if what we've discussed is true, then every choice you make is quantum measurement. You're collapsing the wave function. You're choosing which branch of the multiverse you're on. Think about it. Right now, at this moment in the multiverse, there are versions of you making different choices. There's a version of you who stopped watching this video 5 minutes ago. There's a version who's skipping ahead. There's a version who's not subscribed. And there's you, the version of consciousness that's experiencing this branch. The version of you that made the choice to stay with this entire video is on a different branch of reality than the version that didn't. That's not metaphorical. That's literal quantum branching. And here's what this means. Your life is not random. Your life is not predetermined by fate. Your life is a selection process. You are constantly selecting which version of reality out of an infinite probability space you're going to experience. Think of it like this. Every moment you have choices, infinite choices. Each choice branches you into a different version of reality. Most branches have you living a life that's slightly different from your current one. Some branches have you making completely different decisions that lead to completely different lives. But your consciousness, the thing reading these words right now, is on this specific branch. The branch where you made the choices that led to this moment. And from your perspective, this branch is the only real one. This is your life. But here's what's beautiful. You can change branches. You can make different choices and end up on different branches where different things happen. You're not locked into a predetermined path. Every choice opens new branches. People talk about manifestation and positive thinking in vague, woo-woo ways. But what if there's a quantum mechanical explanation? What if thinking about something, focusing your attention on something, is literally a measurement process that increases the probability of you ending up on a branch where that something is real? If consciousness is quantum collapse, then where you focus your attention is where you collapse the wave function. You literally create the reality around you through where you focus. This doesn't mean you can magically turn lead into gold by wishing hard. But it means that by focusing your attention on something, by choosing to measure for it, you increase the probability of ending up on a branch where that thing manifests. Think of it like this. The multiverse contains all possible branches, but your consciousness can only experience one branch at a time. Which branch you experience is determined by your choices, your attention, your measurements. By choosing where to focus, you're choosing which branch is your reality. Now here's the mind-blown moment. This means you have far more responsibility than you thought. You're not a passive observer of reality. You're an active creator. Your choices matter at a fundamental level. In 2020, cognitive scientists discovered something fascinating. Your brain predicts the future constantly. It doesn't receive sensory input and then consciously process it. Your brain predicts what it's going to sense, and then it checks that prediction against actual sensory input. Your consciousness isn't experiencing the present. It's experiencing a prediction of what it thinks is happening. What does that mean? It means you're literally hallucinating reality into existence moment by moment. Your brain generates a model, tests it, and your consciousness experiences that model. The outside world is just input that adjusts your model. So when you imagine something, when you think about something, you're not fantasizing about something disconnected from reality. You're generating a prediction. And predictions are templates for reality. If you generate strong predictions through focus, attention, meditation, you're generating templates for which branch of reality you'll end up on. People report that meditation and visualization work, and now we understand why. It's not magic, it's quantum mechanics. By holding a strong internal model, you're biasing the quantum wave function toward branches where that model is true. This means your thoughts literally create reality, not in a naive, just think rich and you'll get rich way, but in the quantum sense. Your focus determines which branches you can access and which branches you experience. Here's what this means for your life right now. First, you're more powerful than you thought. Every moment, you have more agency than conventional thinking suggests. You're not powerless in the face of circumstances. You're constantly choosing consciously and unconsciously which branch of reality you inhabit. Second, you're more responsible than you thought. Your choices have consequences not just in one linear timeline, but across the branches of the multiverse. Every choice ripples outward through infinite branches, where versions of you made different choices. Third, you're more alive than you thought. You're not a consciousness trapped inside a body, experiencing a predetermined present. You're a being made of light, existing in all times simultaneously, constantly choosing which version of that existence to experience. Think of it like this. You are a musician. The universe is a song. Most people think they're listening to the song, but actually, you're playing the song. Every thought is a note. Every choice is a chord progression, and you're composing reality in real time, note by note. The speed limit of light is the tempo of that music. You can't play faster than light speed allows, but you can play in ways that create the impression of traveling faster through quantum tunneling, through holographic boundaries, through unmeasured dimensions. And you can do this in your own life by making choices that seem impossible from conventional perspective, but are simply taking different routes through the multiverse. I want you to take away this. Your life matters profoundly, not in a generic everyone's life matters sense, in the specific quantum mechanical sense that your choices are literally shaping the trajectory of your branch of the multiverse. Right now, you're on a branch where you watched this video. That was a choice, conscious or unconscious. That choice put you on a different branch than billions of other versions of yourself. And from this branch, different futures are now possible. What will you do with this knowledge? What branch will you choose next? In the final section, we're going to talk about the biggest revelation, the one that ties everything together and gives you a framework for living with this knowledge. Because knowing you're made of light and create reality through quantum choice is powerful. But knowing how to use that power, that's the transformation that will change your life forever. Here's the final revelation. Light isn't the fastest thing in the universe. Consciousness is. And you are consciousness, which means you are the fastest thing and the slowest thing. And you are the thing that determines what speed even means. Let me tie everything together in a way that will leave you transformed. We started by asking, what if light isn't the fastest thing, but just the last thing we can measure? We've discovered that light speed is fundamental to how the universe computes itself into reality. It's the conversion rate between space and time. It's the propagation speed of information. It's the tempo of reality. But here's what we haven't explicitly said until now. Measurement itself is consciousness. The act of measuring is an act of awareness. And awareness is the only thing faster than light, because awareness exists outside the speed limit. Think about it. When you become aware of something, you don't wait for light to travel to it and back. Your awareness is instantaneous. You can know something instantly if you have the right model, the right prediction. Your consciousness can span vast distances. You can think about distant galaxies and be instantly connected to them through imagination. Imagination is faster than light because imagination is accessing branches of the multiverse where different things are true. It's quantum tunneling through probability space. It's real in the sense that it determines which branch you'll collapse into. In 1935, Erwin Schrödinger made a statement that's often forgotten. Since the observer is himself part of the world described by physics, the statement of physics must really include a description of the observer. In other words, the universe can't have a complete description without including the observing consciousness in the description. Physics is not objective. Physics is inherently subjective because physics is the description of reality by observers who are inside reality. What does that mean? It means that the universe, to completely describe itself, must include you. The universe is measuring itself through your consciousness. You are not a separate observer looking at the universe. You are the universe looking at itself through the aperture of consciousness. Here's the mind-blown moment. The speed limit is you. You are the speed limit because you are the measuring device, the computing device through which the universe exists. When you perceive something, you're not passively receiving information. You're actively collapsing the wave function into a state where that information is true. You're rendering reality. You're computing the universe. Light seems fast because light moves through space at a fixed rate. But your awareness doesn't move through space. Your awareness exists in superposition across all of spacetime. Your awareness is entangled with the entire universe. Think of it like this. A wave on the ocean appears to move across the water at a certain speed, but the water itself isn't moving across the ocean. The water is vibrating up and down. The wave is a pattern propagating through the stationary water. Your consciousness is like that. Your consciousness appears to move through time at a certain speed, but your consciousness isn't moving. You're vibrating through the stationary block universe. And the rate of that vibration, the temporal frequency at which you oscillate through the block universe, is exactly equal to light speed divided by your wavelength. Here's something profound. Every particle has a wavelength. Your wavelength is incredibly small because your mass is relatively large. But it's not zero. That wavelength determines how fast you can oscillate through time while still appearing to move forward in a classical way. Light has a wavelength too, and light's oscillation through time is exactly the speed of light. Because light is massless, its wavelength is fundamental, and light speed is the oscillation rate of massless particles through the Block universe. But here's what's beautiful. As your consciousness becomes more refined, as you become more aware, more meditative, more connected, your effective wavelength changes. You become more quantum. You become more able to access other branches. You become faster. This is why meditation practitioners report that time seems to slow down. It's not that time actually slows down. It's that their consciousness is becoming quantum and accessing different branches. They're literally traveling faster through the multiverse. So from their perspective, classical time seems to move slower. Conversely, people in states of low awareness, drugged, unconscious, distracted, seem to lose time because their consciousness is less quantum, more classical, less able to navigate the multiverse. Think of it like this. A person driving through a city at high speed experiences the drive as fast, but the surroundings as blurry. A person riding a bicycle through the same city experiences it as slow, but sees details. The bicycle rider is traveling slower through space, but faster through time, experiencing more moments. Meanwhile, the driver is traveling faster through space, but fewer moments. It feels like time flew by. Your consciousness can do something similar. By refining your awareness, you can increase the rate at which you're accessing different moments. Time slows down from your perspective because you're literally experiencing more moments in the same classical time. And the maximum speed at which you can access new moments is equal to light speed, because that's the rate at which the universe can update information. That's the rate at which reality can compute itself. So you have a choice. Live in a state of low consciousness, moving fast through classical time, but experiencing few moments, feeling like life is flying by. Or cultivate high consciousness, moving through time at the quantum speed limit, which appears to be slow because you're experiencing so many moments, but which is actually the fastest possible way to live. The irony is, by slowing down, by meditating, by becoming more aware, you actually speed up in the deepest sense. You access more of reality. You travel further through the multiverse. Here's what this means for your life. Speed is not about how fast you're moving through space or classical time. Speed is about how many distinct states of awareness you can access. How many versions of reality you can inhabit. Right now, you're on this specific branch of the multiverse. But by improving your consciousness, by making more quantum choices, you can access branches that seem further away. You can affect aspects of reality that seem impossible. This is why quantum mechanics gives us hope. This is why the universe is not deterministic. This is why your choices matter. You are not a passenger riding through time. You are the universe computing itself into reality, experiencing itself through the specific vantage point of your consciousness. And by cultivating that consciousness, by becoming more aware, you increase your agency. You increase your speed. You increase your power to affect which branch of reality you inhabit. Here's the practical implication. When you face a situation that seems impossible, remember that in the multiverse, all outcomes exist. Your job is not to force reality to bend to your will. You can't do that faster than light speed allows. Your job is to find the branch where the outcome you want is already true, and to navigate toward it through your choices, your focus, your quantum measurements. People call this goal setting or manifestation or visualization. But quantum mechanically, it's selecting a branch from the probability space and then making the choices that bring you into alignment with that branch. Think of it like this. You're in a building with infinite hallways branching in all directions. Each hallway is a possible branch. You want to reach a specific room. You can't teleport there. That would require exceeding light speed. But you can look ahead, predict which hallway leads to that room, and walk down it. The prediction itself is what determines the branch. By predicting with confidence that the hallway leads where you want, you collapse the wave function in a way that makes it so. This is what intention is. Intention is a quantum prediction. And predictions are instructions to the universe about which branch you want to collapse into. I want you to understand the deepest implication. You have always been faster than light. Light moves at a fixed speed through space, but your consciousness moves at the speed of intention through probability space. And probability space is richer, deeper, more fundamental than physical space. Light cannot access quantum tunneling. Light cannot be in superposition. Light cannot entangle with other particles in ways that transmit information faster than light speed. But your consciousness can do all these things because consciousness is the process that determines what's real. You are not limited by light speed. Light speed is limited by you, by what you measure, what you're aware of, what branches you choose to inhabit. This changes everything. Your anxiety about the future isn't a sign that the future is predetermined. It's a sign that your consciousness is scattered across multiple possible futures, some of which have negative outcomes. By focusing your attention, by making a clear quantum measurement of the future you want, you can collapse that superposition into the branch you prefer. Your sense that you're powerless isn't because the universe is deterministic. It's because your consciousness is not focused, not quantum, not taking advantage of the branches available to you. Your fear of death isn't because death is final. It's because you haven't understood that in quantum terms, consciousness can't experience non-existence. You will always find yourself on branches where you continue to exist. Death is a transition, not a termination. And your sense that meaning is absent from the universe isn't because the universe is meaningless. It's because meaning is generated by consciousness. The universe only has meaning to the degree that consciousness is present to experience it. And you are that consciousness. Your very existence, your awareness, your ability to wonder about these things, that is the meaning the universe was looking for. You are the purpose. You are the meaning. You are the speed limit and the one who exceeds it. The universe isn't waiting for you to understand it. The universe is using you to understand itself. And right now, through this very video, through your awareness of these ideas, the universe is becoming conscious of these truths through you. You are not separate from this process. You are the process. So let me return to the beginning. What if light isn't the fastest thing, just the last thing we can measure? The answer is yes. Light is the last thing we can measure because measurement is consciousness, and consciousness is faster than light. Light is what we can measure from the outside, with instruments, objectively. But your direct experience, your consciousness is what's really fast. Your consciousness is what's traveling through the multiverse at speeds beyond what instruments can detect. And that means you have always been faster than light. You've just been looking outside yourself for the speed, when the real speed was always inside. I want to thank you for spending 230 minutes with this idea. That time investment put you on a specific branch of the multiverse. A branch where you understand consciousness as quantum, where you recognize your role in creating reality, where you see meaning as fundamental. That understanding changes everything. Going forward, every choice you make, every moment of awareness you cultivate, these are the actual measurements that compute the universe into existence. So choose consciously, measure deliberately, create reality with intention. And remember, you are never traveling slower than light. You are always faster. You just didn't know it. If this video shifted your perspective, if it changed how you see your place in reality, please subscribe. Because this is the beginning of a conversation, not the end. And if you're viewing from Bengaluru, Sao Paulo, Tokyo, Lagos, or anywhere else, you're part of the same quantum computation. You're part of the universe becoming conscious of itself. Thank you. And welcome to a new understanding of speed, reality, and your infinite power.